Okay, so centroids are the balancing points of a shape. So if you were to take a piece of paper, fold it in half, you see a giant line right there that tells you that's the balancing point of that shape. What we're going to do is we're going to be able to take multiple shapes and put them together and calculate how those shapes affect each other. So the big thing to consider is the bigger the shape, the more influence it has on the balancing point of that shape. Just like the meter sticks and the weights that we did a while ago, that was a way to see the influence of that turning force. So the reason we do centroids is to determine center of mass, so that objects as they're being built, if they are properly in the center of mass, they will not collapse and break. So with this, we're going to take a shape. Now, the thing about centroids is we're treating it as if we have an origin point, a point where we're referencing everything from that spot. So it could be bottom left, like a standard Cartesian grid. It could be way up here in the corner. That doesn't matter. As long as you are calculating it from the spot that you choose, then you're going to get measurements in the direction that fits. So for us, we're going to do bottom left because that makes everything nice and positive if we're adding and negative if we're subtracting. If we don't, it gets really funky and we don't really want that. So we got the shape. It is a complex shape that we're breaking it down into a square, a triangle, and a hole. So with a hole, you're taking away any measurements and mass. So you want that to be a negative number. So this table right here is going to help you keep this information organized because um, once you have all that stuff in the table, you can plug and play into these formulas to figure out the x point or the x part of your point and the y part of your point. So we would just take the sum of the data, and I'll talk a little bit more about that. But first, we got to get our area and our centroids. So of each individual simple shape. So rectangles, squares, areas, length times width. So this is 36 because we've got our origin point from 0 to 6. So our length is 6 and our width is 6 as well. So 0 to 6. So 6 times 6, 36. Now our triangle is zero point 0.5 length times width. And so zero point 0.5 multiplied by 6, 6 to 0, multiplied by 8. So 14 minus 6, that'll give us 8. And that would be 24.5 times 6 times 8 is 24. Now, a circle is pi r squared. This circle right here, the radius is 2. So that would be pi times 4, which would then give us 12.57. And remember, it's negative because we're taking away mass from there. So it affects it in the opposite direction. All right, now we're looking for our x centroid. So the nice thing about this is with squares and circles, it's pretty common sense. You just fold it in half. So a rectangle, the x is you're going from the x and you're finding that center point as if you were folding the shape in half. So that would be a 3. We're going to do the same thing with the circle. The point is right in the center. It is 3 spots away from your origin point, and that's the thing you got to consider. It's that centroid is how far it is away from the origin line. So that is also 3. Okay, same with y. You're folding it, so 3, 3, and then the triangle has a little bit different of a formula. It is a third of the distance of your length or your width of x and y. So 1/3 of your length, 1/3 of your width is going to give you your centroid. So we're doing length. That's going to be, we're treating that as our length instead of our height. So 1/3 of 14 minus 6, giving us 8 down here. And that's going to end up being 8.67. Now, hold up. Where in the world did you get the 8.67, Alex? You have to consider you're starting at 6. So 1/3 of our length, 14 minus 6, that's going to end up being right about here. But then you take that and you add it from 6. So it ends up being like 2.67 is the centroid of the triangle. But we have to consider the origin point, which is why it's 8.67. All right, our length, much easier. It's 6 high, so 1/3 of that is 2, and we are sitting on the origin line, so it does not change other than the calculation that we got for the shape. All right, so we have everything on the table that we need to solve for our centroid. So we plug and play. There's 3 things you're going to be doing. You are going to multiply. You are then going to add, and then you're going to divide. So we're going to start with the x centroid first. This symbol is sigma. This represents adding everything inside the parentheses. So we are adding a of I times x of I. Now the I represents the number that you're associating with. So a of I times x of I means the sum of a of 1 times x of 1 plus a of 2 times x of 2 plus a of 3 times x of 3. That is your sigma a of I times x of I. So we're going to walk through that. Shape 1 is 36 for your area times 3 for your centroid. Shape 2 is 24 for your area times 8.67 for your centroid of that shape. Number 3, shape 3 is negative 12.57. Remember, it's a whole, so it's taking away from our total times 3, and that is going to be added together to give us 278.37. Now that's the top line right there. Then you divide it by the sum of all the areas together. You treat them like parentheses. Do it before you do the dividing. That's why it's multiply, add, divide. So 278.37 divided by 36 plus 24 minus 12.57, giving you your centroid of 5.87. So that is right here. 5.87 is on this line right here. So if you were to fold this shape in half right there, it would balance on that line. Okay. Now we're going to do the same thing for y. Multiply, add, divide. So shape 1, a of 1 times y of 1. 36 times 3. 24 times 2. And negative 12.57 times 3. You add it together, 118.29. Then divide it by the sum of your area, giving you a centroid of 2.49. So your centroid is right there. That, if you were to put that on a point, it would balance that shape right there. And that is how you calculate a centroid. Now, for the assignment today, you are going to get onto Magic School. You're going to go talk with the AI agent, and you're going to work through a problem together. It is really helpful to be able to work through it. I asked somebody in my family to walk through it who does not know how to calculate centroids, and by the end of it, they got it. They understood how it worked, and it worked them out. There were a bunch of points where they were like, I don't know what I'm doing, so they threw in a random answer. The AI said, okay, I see that you don't understand it, and they helped work through the problem with them. So your assignment is to get on and work through a problem together until you can find an answer for it. Once you do that, you're done, and you'll be able to move on. But this is a good start for understanding how centroids work altogether. Yeah, be honest with it. If you don't know, tell it you don't know. It's going to walk you through, and it's going to ask you questions to help you get to the point where you'll be able to be confident with it. You've got this.